Welcome to our last video on Piecewise. We are now going to do some hyperbolas. You should realize that x cannot be -3, that we're going to have a vertical asymptote at -3. So I'm going to put in my vertical asymptote over here. And when I ask what's the horizontal asymptote, well, 0x over 1x gives you a 0, so it's going to be the x-axis. You should have had some practice when you graphed these earlier, where you just simply said, I'm going to go a half away, 1 away, 2 away, because its other name is the reciprocal function. So, since the numerator is positive, when I go half away, I'm going to go up 2, 1 away, up 1, 2 away, up a half. And so I'm going to get this cute little segment. And because we have now pretended like this is our y-axis, it's symmetric across the origin because it's an odd function. So a half left will just go down, 1 left will go down 1, and 2 left will just give you the half. You just negate these ordered pairs and count them off the line. Let me get that better. And so now we have our hyperbola. The ordered pair, -3, 4, 1, 2, 3, 1, 2, 3, 4 is right there. So we have a nice hyperbola. So what do we know about this? It's not only the left, but it's also the right, because not equal to means less than, or it means it can be greater than. So this is your 1 over x plus 3. This is also 1 over x plus 3. What's happening on the left side? I'm going to have 1. I'm going to plug it in and get 0. When I plug a number in like -3.1, it will be negative. So this is heading to -infinity. Notice the graph agrees. Over here, I get 1 over 0. Slightly to the right is 2.9. That makes it positive, so this is positive infinity. Note the graph agrees. The infinities don't match, so it's D and E. I gave you a function value. There it is. It's a cute little 4. So we're just showing you that you can get these vertical asymptotes, and yes, you're going to get the infinity answer that just describes the behavior. We know this doesn't exist, but it's heading down towards Satan, and we know this doesn't exist, but it's heading up towards Jesus. Now in the middle, we give you another one of those absolute values, but notice it's now got a negative x in it. So let's see what happens. What makes the inside negative? Well, what makes the inside negative is actually going to be a number bigger than 2, like 3, 4, 5. So when I see that my x is negative, I put the negate answer down there for negative and the positive answer up here, because we like to say less than first and greater than second. We just like the number line. Now some textbooks will actually do greater than 3, then less than 3, or greater than 2, then less than 2, or greater than -4 and less than -4. They will go ahead and confuse the dickens out of you by not putting them in number line order. But you notice that x cannot be 2 at all. And so to the left, in other words, what makes it plug in a number like 1 or 0? And what am I going to get? A positive. And what happens when you're a positive? What you see is what you get. And so this answer is now +1. What happens when I put a number bigger than 2, like 3, 4, or 5? It's a negative. And what do you do when you have an absolute value of a negative number? You negate it. And so now this is going to be -1. Instead of the standard graph below, above, it's just going to change places. This is going to be high, and this one's going to be low. So we'll notice this is my 1, and this is my -1. We will notice that the ordered pair here is 2, 1 open, and 2, -1 open. And so when I plot my 2, 1 open, I'm going to go left and see it was actually positive, and my 2, -1, and I'm going to go right, and all they did was reverse where they were, and that should make sense that I'm negating the positions because I'm negating the x. Notice these are 2 real numbers. They don't exist. It's D and E. I know you're shocked. You see a jump. We realize this is the indeterminate 0 over 0, so this is indeed undefined. Now for the last one, we're going to go back to one that's similar to the first one that we did. When I come in, oh, what's wrong? Instead of my graphs going to be like this, they're going to just turn places because that's a -1. But I have a vertical asymptote, and I know this means x less than 2 or x greater than 2. So this is to the left and right of 2. So, can't copy. So I have x minus 2 and -1 over x minus 2 for this one. 1, -1 over 0, 1.9 makes it negative. This will be positive infinity. 1 over 0, 2.1 will make this one positive, but that's a negative on top. So that's negative infinity. Our graphs should match. D and E, because they don't match. And again, I gave you a function value, so I know it's going to be -3. So let's look at our graph. On our graph, our vertical asymptote's going to be at 2. And so it's not to blow your mind. Notice the degree of the top is less. So 0x over 1x would give me a horizontal asymptote of 0. And so if I were to graph this function, again, I would be thinking the numbers 1/2, 1, and 2, and taking their reciprocals. But what's on top is a negative. And so this is going to occur. I just have to negate all those. So I come over here, and when I go a half left, I go 2 down. Right, I meant. And when I go 1 right, I go 1 down. When I go 2 right, I go a half down. And there is the 1 branch. And because this is symmetric about the origin, I can now make this negative, positive, negative, positive, negative, positive. So when I go 1/2 to the left, I'm going to go 2 up. 1 to the left, I'm going to go 1 up. 2 to the left, I'm going to go a half up. Now, if you don't know that pattern and you want more information about it, I will indeed help you with it. People, you need to know that for college. If you take calculus or you're going to be in pre-calc or something, they won't always say use your calculator. Now, the ordered pair is 2, -3. It doesn't help us out at all. This is still going to be an infinite, and I forgot to write that in the first one, sorry. Infinite or vertical asymptote or unbounded discontinuity. Okay, we can't do anything to fix it. Let's go back to the first one. We know it's infinite, if you want to call it that, or you could call it vertical asymptote or unbounded. College books all do this. The AP seems to like to use these two ideas a lot. You need to know all three of those names, just to be quite honest. Now, this is the last of the videos. You're going to do a worksheet 2, a worksheet 3, and a worksheet 4. They each have 6 problems on them each, and they're a review of everything that we have done thus far. But I have gone slowly through this worksheet, and we've just you've just done 3 problems a day to try to help you learn how to do these.